morning, everybody. Today we are going to go over 5.1 and 5.2. This is going to be a really nice break after Unit 4 because it is quite a bit easier. You have actually learned about law of cosines and sines very briefly before in Algebra 2, so this will just be a review of what we learned. I do ask that you guys have a calculator handy. Can you give me a smiley face if you do have one nearby? That way we can practice plugging in for our angles. That would be awesome. We're taking a little bit of a different approach today to Unit 5. What I have done is I've actually pulled out actual quiz questions today. And typically on a quiz they give you there's three different versions of each quiz. So I took one version of the quiz and completely deleted it and I'm using those questions with us today. So your quiz questions are going to look very similar just with different numbers because I want you to get the way that they're asking you the question down and to really understand what they are looking for in Unit 5. So hopefully this will be very helpful to you. I did file transfer a copy of the PowerPoint. If you ever want to print that out and write on top of it, that would be my preference just because then you're not spending the whole time writing down the question. But if you don't have a printer handy, then obviously just make do. So for week 13, that's what week we're in, my question to you this week is what kind of triangles are you able to use the law of cosines with? What kind of triangles are you able to use the law of cosines with? We're going to answer that in two different ways today throughout our session. I'll put that up again at the very end if you need it. So let's start off with the basic question here. How can you prove if a triangle is a right triangle? Can any of you guys answer that for me in the chat area? If I'm asking you, if here's a triangle and it has sides 1, 2, and 8, how can I know for sure if it's a right triangle or not? You guys are both right. Pythagorean theorem. So I'm going to try the Pythagorean theorem and I'm going to check it out. So I'm going to say, does a squared plus b squared, does that equal c squared? See how I put a question mark in there? I need to check and see if it does or if it doesn't. So I get a 1 plus a 4. Does that equal 64? So no, absolutely not. So this one is not a right triangle. It's still a triangle, it's just not a right triangle. Everybody okay with that idea? So that's how you can prove if something is a right triangle or not. Now, if it was a right triangle, our favorite way and our favorite method to solve right triangles is SOHCAHTOA. Right, our sine, cosine, and tangent. That's what we're used to using anytime I have a right triangle. What we're going to learn this unit is that you don't always get a right triangle. Sometimes we have non-right triangles. So I'm going to teach you two different case scenarios today. The first one is the law of cosines. And here's what's cool about the law of cosines. Yes, it still works with right triangles, but guess what else it works on? Non-right triangles. So that would be if it has an acute triangle, or if it's an obtuse triangle, we are able to use the law of cosines. Okay, here's the law of cosines down here. If you want to just quickly write down one of these. So yes, good question. So does the law of cosines work with all triangles? Yes, it does, because it works with obtuse, acute, right. Now, if I give you a right triangle, it probably would not be my first choice to use one of these funky equations. Anytime you have a right triangle, you probably want to use SOHCAHTOA. But I'm just letting you know, yes, it still does work with the right triangle. So go ahead and write down one of the three. These are all they're all exactly the same, just the letters are changing places. This will make more sense when we try one in just a moment. Couple things I want to point out to you in the formula. Whenever they use the capital letter, that they're talking about the angle. That's the angle. When they use these lowercase letters, those are your sides or your side lengths. Does that make sense, the difference between the two? So here's my capital A, because that's my angle. Straight across from it is where we find our little a. And then B and C would be your other two sides. Capital B's across from your little b, capital C straight across from your little c. Now the online slides for 5.1, they really do a good job of proving to you that this is just another version of the Pythagorean theorem. Kind of cool. So Pythagorean theorem is always true when you have a right triangle. What the online slide showed you is that sometimes if you get your a squared plus your b squared is greater than c squared, and sometimes you're going to get a squared plus b squared is less than c squared. And when those are the cases, it actually reduces to the law of cosines form. So they do a great proof for you online. I just want you guys to understand that law of cosines is really just a different version of your Pythagorean theorem for when we do not have a right triangle. Can I get a green check mark if you are done taking notes and ready to move on to the next slide? Fabulous. So let's try one. Hint, hint, might be a quiz question. Okay. It says, calculate cosine theta to 2 decimal places. So I want to find this one right here. So let's look back at our law of cosines. And I'm actually going to label each side. So let's call this angle A. If this is my capital A, then that makes the 8 my A. And which ones do I make B and C? It doesn't matter. I can call either side B and either side C. You're going to see why in just a second. Oops, I didn't mean to show you the answer already. I meant to do the problem with you. Okay, so let's try this problem. So if I'm looking back at my, let's peek back here for a second. If I'm looking back here, when we want to find the angle, we can use this alternative form because here the angle is the one that I don't know. On the left-hand side, if I want a squared, I would use this side when it's the side that I don't know, the side length. Because remember, the little letters are your side lengths, the capital letters are your angle. So when I look at my problem, which one do I not know? I know all my side lengths, right? I don't know my angle. So I'm going to use the one on the right. I'm going to use this one right here. So let's write that formula out. So I have cosine A equals b squared plus c squared minus a squared over 2bc. So let's fill in our numbers here. So I have cosine A equals 11 squared plus 7 squared minus 8 squared all over 2 times b times c. Let me give you just a second to copy that down and then we'll solve it together. Here's why it doesn't matter which one you label B and C. Okay, nobody asked this question. I'm just putting a hypothetical out there. Look what you're doing to your B and your C. You're squaring them and you're adding them. That means if you swap their places, it doesn't matter. It's not going to change your problem. The only one that matters that you label correctly is your a squared, because that one's a subtraction sign. So I know that I picked the right a if it's straight across from my angle. See how I know I picked the right one to say minus 8 squared. The other two doesn't matter. I could have labeled this one B and that one C. Doesn't matter. The only key one is that across from the angle you're solving, that those letters match. If I use a capital A here, I have to use a lowercase a straight across. So let's finish solving. So once I solve my top, I get 106. Once I solve the bottom, I get 154. So when I divide that fraction, I get 0.688. So sometimes they're going to ask you to leave your answer in decimal form. In this case, they said calculate cosine theta. So we found that theta, cosine theta, equals 0.688. That's not the angle measure. This is what they're asking us for, because this is how they got the 0.69. But what if I asked you what the angle was? Do you guys know how to take it from here and actually tell me what degree that angle is? What do I have to do in my calculator? If instead of the decimal version, they want the angle version. Anybody know how I get rid of the cosine? How do I get theta by itself here? Because this is coming up on the next slide. It's been a while, but it's not too tricky. So think about this. If I have 2x equals 0.688, how do I get rid of the 2? I divide by 2, right? And then I would get my answer. So over here, how am I going to get rid of a cosine? Anybody know? We're going to do cosine to the -1. Or in other words, we're going to do the inverse. So do we have our calculators handy? I want everybody to type in second cosine. So you should see the cosine to the little -1 symbol in your calculator. Do 0.688. Enter. In the chat area, can you let me know what you got? Let's see, how many degrees is that angle? And this is why I'm having you guys check. Because some of our calculators are not in the right mode. So Dakota and Nicole, you guys need to switch your calculators to degree mode. So if you click on mode, I want you to switch from radian to degree. And then try the problem again. Now your answer will be in degrees. Were we able to find that button? Mode is usually in the upper left corner. There we go, excellent, yes. So we're gonna get 46.528. So my degree would actually be 46.5 degrees. Aren't you glad I had you check? So sometimes, again, they're going to ask you to leave it in decimal format like this answer did. Sometimes they're going to ask you for the degree format. If they want the amount of degrees that that angle is, we have to make sure that our calculators are in degree mode. And don't worry, the first time I solved this problem, I got the exact same decimal as you guys did, and then I thought to myself, wait, that should be an angle. They want degrees, so I had to check my mode. So let's try this one. Suppose a triangle has two sides of length 2 and 5, and that the angle between these two sides is pi over 3. What's the length of the third side? I'm a visual learner, so let's draw a picture. It tells me that a triangle has two sides, one's a length 2, one's a length 5. And the angle between them is pi over 3. Can I get a smiley face if you are with me so far? Okay, fabulous. Okay, so this time let us set up our law of cosines. So we're going to say cosine A, let's call this A again. We'll call this side A, which makes this my little a. Let me switch colors and it will stand out a little bit better. So here's my big A, here's my little a. B and C doesn't matter which one we label them. So let's write out our formula. I have cosine A equals B squared plus C squared minus A squared over 2BC. Let's try plugging in our numbers. So this time, I know my angle. I can say cosine pi thirds equals, is everybody okay with why I did that? Because this time I know what my A is, so I'm going to put in my pi thirds. All right, let's keep going and putting in what we know. So my B squared would be 2 squared plus 5 squared minus, I don't know, oops, not a subtraction, a minus sign. I don't know A, so I'm just going to leave it A squared over 2 times B times C. I just need to solve for my A squared. So this kind of goes back to Algebra 1, getting a variable by itself. This, of course, this one's a little more complicated than Algebra 1, but we're just going to combine some like terms. So on top, let's say 2 squared plus 5 squared. So 4 plus 25 gives me 29. And on the bottom, I have 2 times 2 times 5, so that would be 20. Do any of you have your chart handy? The one that has your radians to degrees, it has all the trig identities on it. We need to look up what cosine pi thirds is. It's a really easy number. Anybody have it handy? So look up what is cosine pi thirds. Excellent. 1/2. 1/2 equals 29 minus a squared times 20. Okay. How am I going to solve for here? Any ideas? What should I do next step? Still trying to get a squared by itself. What do I want to do? Yep, let's get rid of the divide by 20. So let's multiply both sides by 20. You got it. Times by 20 makes those go away. Times by 20. So I'm going to get on the left side, 1/2 of 20 is just 10. So 10 equals 29 minus a squared. See how close we are? Let's move my 29 over. So I'm out of space. Sorry for my crazy work here. So we get negative 19 equals negative a squared. Let's get rid of the negative. Just divide both sides by a -1. So we get 19 equals a squared. How do we get a by itself? Very last step. To go from an a squared to an a, square root both sides. So a equals square root 19. And that's what they had as the answer over here. So what I want to show you guys is that even though when we first start, you can still use the same formula, you just got to plug in what you know. So this time we knew the angle, so I'm going to plug in my angle. I had an unknown in there, so I just solved for my unknown. So that's one way to do it. Or let me show you one other thing you could have done. When they give you all of these different forms, see how they give you these 3 and they give you these 3? If we didn't know our side, we could have used this formula. You guys see what I'm saying? Because you did know your A, you did know your B and your C, and all of that would have given you your a squared. So what I'm trying to show you is it doesn't matter if you want to start with your alternate form or your standard form, you're still going to get the same answer. It's just whatever one you think is going to be easier for each problem. It's your choice. These are the same equation, just in slightly different formats. Any questions about how we got root 19 before we move on? Is this section already feeling a little easier than Unit 4? It's more mathy. You know, it's not proofs. It's just, let's do the math. Okay, I'll move on, but Nicole, if you still have a question, I will go back. Okay, let's try this one. This one says, use the law of cosines to find the value of 2 times 3 times 4 cosine theta. So before I can solve this problem up top, I need to figure out what theta is. So let's come down here, and we're going to use our law of cosines. So what side of the equation do you think we should use? Should we use the left side where we're solving for a side, or should we use the right side where we're solving for an angle? What do you guys think? There's not a right or a wrong answer, by the way. Yep, I agree. I think we'll use the angle formula. So let's do cosine A. Again, I'm going to call this A. So let's always label your triangles, please, on your paper. That way you are not going to make a mistake and you can keep things super clear. So across from my angle A, I have my little a. The other two get B and C. Again, doesn't matter which one's B, which one's C. So here we go. B squared plus C squared minus A squared. Here's how I keep my formula in my head too, just so you know, so I don't always have to keep looking back. Whenever you're doing this angle right here, you're squaring the two sides that are touching it. So it's this side squared plus this side squared. The one that's subtracted is always the one that's straight across. Isn't that kind of helpful? So the first two parts are always the two sides that are touching the angle, and then the part that's subtracted is always the one that's straight across from it. So it's kind of helpful. And then on the bottom it's 2BC. So 2 times each of these two, the same ones that we squared and added together on the top. Let's fill in our numbers. So I have cosine A equals 3 squared plus 4 squared minus 2 squared over 2. My B is a 3, my C is a 4. So let's work that out. I'm going to get 9 plus 16 minus 4. So that would be 21 on top and a 24 on the bottom. So our cosine A equals, what is 21 divided by 24, by the way? 0.875. Okay, but I want to know what theta is. That means I want to know what the angle is. These are not the angles. We'll come back to how they got that answer in a minute. But before I move forward, can you guys just tell me what angle A is using your calculator? So we got cosine A was 0.875, but what does that make angle A? So remember how we plug it in? Good job, Nicole. So when we plug it in, you're going to do second cosine, so you get cosine to the -1 of 0.875, and when you plug that in, we get 28.955. Well, if it's 0.95, we're going to round that to 29, because even if we rounded to 1 decimal place, the 5 would bump the 9 up. Everybody okay with saying 29? But 29 is not an answer option. You know why it's not an answer option? Because my original question is asking me to solve this. My original question wanted me to solve 2 times 3 times 4 cosine theta. Well, we just found theta to be 29. So please type this in your calculator, and it's going to be, you should get 21. So let's all try. 2 times 3 times 4 cosine 29. And you get 20.99, which is why they picked 21. Can I get a smiley if you got that in your calculator? Make sure we're in degree mode. Okay, great. So I hope that you're feeling a little more confident, a little more comfortable. So that is how we use the law of cosines. I want to point out one more thing before we move on. What kind of a triangle was this? What kind of, I guess I should give this one to you so you know what I'm asking you for. This triangle where we were able to use law of cosines was a side, angle, side. Everybody see that? So when am I able to use law of cosines? Well, I was able to use it when I had a side, angle, side. Can I get a check mark if that makes sense? When else am I able to use law of cosines? What kind of a triangle was this? What information did I give you here? Good job, Dakota. This one is a side, side, side. So I'm also able to use law of cosines when I give it to you as a side, side, side triangle. So you know 2 so far, 2 kinds of triangles that we're able to use law of cosines with. So now we're going to jump into law of sines. Here's what's also cool about law of sines. Law of sines can be used with right and not right triangles also. So that's kind of cool. I like law of sines the best because it's super easy to remember. It's sine A over A, sine B over B, sine C over C. It's really cool, really easy. So it's saying the sine of the angle divided by the length equals the sine of another angle divided by its length. It does not have to be all 3 pieces of the puzzle. You can just, we usually typically use it with 2 at a time. But what they're telling you here is that it does actually work where all 3 are in that proportion to one another. So it's going to make sense when we try one here. So sometimes you're going to have this big obtuse angle out here and it's going to work. Sometimes they're all going to be acute angles and that's also going to work. So kind of cool. So let's try it. So here's our first example. Let me give you just a quick minute to copy down the triangle, and then we will set up our law of sines. So again, we do the sine of the angle divided by the side equals the sine of the angle divided by the side. So let's set this up. So I have the sine of 45 over its side, which is x. Everybody okay why I matched those two together? So 45 is pointing at its opposite side, which is x. That's going to equal the sine of 120 divided by its side. Any questions how I set that one up? Are we okay with my proportion up there? Okay, going back to Algebra 1, how do we solve proportions? We're going to cross multiply and then solve. So I'm going to get 10 times sine 45 equals x times sine 120. Remember, our whole goal is to get x by itself. So can somebody tell me my last step? How am I going to get rid of that sine 120? Ooh, good job, Nicole. My mind didn't even go there. Yes, we're going to do that in a minute. But first, let's think back. Let's do a basic problem. I'm probably asking this in a funny way. How do you get rid of the 2? Divide by 2. So how are you going to get rid of the sine 120? We're going to divide by sine 120. See how now I have x by itself? So x is going to equal 10 times sine 45 divided by sine 120. Now, our calculators would give us a really nice decimal answer if I type that into my calculator. But what if a quiz says, give me the exact value? That means no decimals. Well, then Nicole already typed in the answer. She said we're going to use our unit circle, and that's absolutely correct. So can you guys look up what is sine 45? What am I going to replace sine 45 with? With an exact value, no decimals. Are we looking at our chart from our identities chart? Sine 45, I know I have it here somewhere. So sine 45 is root 2 over 2. How about sine 120? Use your identity chart. Check out what is sine 120. Sine 120 is root 3 over 2. So again, you guys do not have to have those memorized. You can just use that chart. We have one last little step to go. I just have to simplify. So I'm going to take this big division bar on the bottom and I'm going to change it to multiply by the reciprocal. So I'm going to multiply that by 2 over root 3. So my 2's are going to cancel. They're going to go away. And I'm going to be left with 10 times root 2 divided by root 3. That would be your exact answer. So anytime on a quiz, on a test, on your checkup, if it says exact value, that means you got to do all of these steps and just look at the trig identity chart to find out their exact values. Does that make sense versus a decimal answer? So exact value means leave it in root format using your chart. Excellent. Okay, great. That was just the answer, which we already got to ourselves. Okay, let's try this one. It says in the following triangle, find the values of the angles B and B prime, which are the best approximations to the solution to this ambiguous case. It's a lot of nonsense. The words are a lot of nonsense. So let me give you just a second to write down the question, and I will help you work through it. Will you give me a check mark once you have it on your paper? We're going to start with finding b, meaning we're going to start with this big outside triangle first. I'm highlighting the big outside triangle here. We're going to try and find b. So let's all set up law of sines trying to find b. So it would be sine b is 2. What's straight across from sine b? We're forgetting that this middle section's here for now. See how I'm crossing it off? What side is straight across from the big B? What value is going to go in my denominator? Good job. Yes, 10. Now on the other side, I'm going to have sine 45. And what's straight across from the 45? 8.2. Let me give you guys just a second. I want you to cross multiply and try and solve for angle B. I want to see what you guys get as your answer for angle B. So how did you do? Does your work match my work? So we have 8.2 sine B equals 10 sine 45. We're going to divide both sides by the 8.2. So let's figure out this side right here. So if I type in, well, first of all, how am I going to get B by itself though? Do you guys remember how am I going to get rid of sine? How am I just going to find the angle? What do we type in our calculator? Exactly. You have to type in sine to the -1, and then you're going to do this whole right-hand side. So let's try, and let's see what you guys get. Because it's important to practice when you know what the right answer should be, so that way you know that you know how to type it in correctly. Okay, so I just typed all that into my calculator and all in one thing, and you should get 59.6. If you didn't get 59.6, I want you to keep practicing in your calculator because now that you know what the right answer is, you might have just missed a parenthesis somewhere. So we found that B is 59.6. Let me erase all this other nonsense that I put on there. And let's take a peek at the picture again. So it does ask us, find the values of B and B prime. If you notice, there's only one option that has your B as 59.6, but I still want to make sure you understand how they get B prime. Take a peek at this part of the triangle here. This is 8.2 and this is 8.2. That means that this is an isosceles triangle, right, where our two sides are the same. So if our two sides are the same, guess what that means about these two base angles here? They are also the same, right? So that means this one in here and this one right here, they're the same. So that makes this one a 59.6. How could I solve for B prime if the angle right next to it is a 59.6? Anybody remember geometry? How do I do that? If this one right on the other side is 59.6, I have a way to solve for B prime. Yes. It's going to be 180 minus 59.6 because they're both on a straight line, which means they're supplementary angles. They add to 180. So I'm just going to do 180 minus 59.6, and that's how they get their 120.4 for B prime. Everybody okay with that? Because doesn't B prime, even from the picture, it looks obtuse, right? It looks like it's greater than 90. So 120 makes sense. B was an acute angle. B prime is an obtuse angle. So everybody okay with this question? Always start with your outside triangle first whenever they give you two angles. It will make your life much, much easier. Let's come back here for a minute. What kind of triangle was this? Remember when we were talking law of cosines and we said side, side, side worked, side angle, side worked? For law of sines, what kind of triangle is this one? Anybody want to try? There's two correct answers. What kind of triangle is this? This one's an angle, angle, side. That wasn't one of ours that worked with Sakatoa, but guess what? This is okay now because now we're talking about non-right triangles. How else could I write this? I could also say that this one is a, if I'm circling my other letters, a side, side angle. It's one of those that we used to say, hey, no bad words, those don't work for congruence properties, but they work now because we're talking about non-right triangles. So these two work with sine, law of sines. Just something good to keep handy in your notes. Okay, last question. This says calculate the side lengths A and B to 2 decimal places. This one should be pretty simple because, well, except for one reason. Let's talk about why I threw this one in here. If I started to set this one up, I could say sine 50 is to A as sine 107 is to B. Okay, let's write that out, what we have so far. Sine 50 is to A as sine 107 is to B. What's my problem here, though? Does anybody see a problem? There is a problem. I'm letting you know that there is a problem. Well, I matched them up, right? I said A is to A, B is to B, so I set it up correctly. I have two variables. I can't use law of sines if I have two variables. Law of sines only works if I only have one unknown. And then here, you know that this side is 8, but do you know that angle? So think about my last question. You know this side is 8. Do you know that angle? Because right now, I can't solve it like it is. That's not going to work for us because I have two unknowns. What if I'm telling you that you know angle C? What do we know about triangles? We know that all three angles are going to add to be 180. So if I know two angles, don't I automatically know the third angle? I do. So even if they don't tell me what it is, I do know what it is. So I'm going to add them together plus my unknown, and it's going to equal 180. So if I do 180 minus 107 minus 50, I find out that C is actually 23 degrees. You guys okay with how we found that one? Nicole, you got it perfect. So let's not use this one because I can't, because I had two unknowns. So we're going to use angle C and say sine 23 is to 8 as, and I'm just going to do them one at a time. So let's do sine A first. Sine 50 is to A. Any questions how I set this one up? Are we okay with that? Okay, you try and tell me what angle you get here, or what length you get here for A. This time it's a length. So just plug that in your calculator and let's see what we get. I would hate for you to have all the work right, but then you'll get the wrong final answer. So what is the length of A? Excellent answer. Perfect. Usually when I'm typing a really long problem into my calculator, I will do the whole top half, hit enter, and then just type in divide by sine 23 and hit enter. Because with your smart calculators that you are probably using, if you just type in the top and hit enter and then you type in divide, it's going to say answer divided by this. It will store what answer you have from the top in your calculator. So the correct answer is 15.7. Good job. And again, if you're not getting this in your calculator, then it's you trying to figure out what you're doing wrong and how you're typing it in incorrectly. So I want to show you the right answer. I'm confident that once you have one, you'd be able to find the other. You would just set up another trig function. Last question of the day is this one. It says, how many solutions does a triangle with sides 4 and an angle of 68 degrees and another side of 10 have? And you may be thinking, wait, how could there even be more than one solution? Let's think about triangles for a minute. If I give you 3 lengths of a triangle, your options are for it to form a 90 degree. Your options are for a 3, 4, and 5 to form an obtuse. Or if it's pointed the opposite direction, I'm trying to see how best to draw this. I'm not a very good drawer. Or it could be an obtuse. So you could have one exact answer. You could have 2 exact answers. Or do you remember from geometry how sometimes if I give you 2 numbers that it's not a triangle at all? That there's no way that a side of 1, a side of 2, and then a side of 8 could even make a triangle? Do you guys remember that at all from geometry? You could try with pieces of paper that are 1 inch, 2 inches, and 8 inches. So sometimes when you try and put these 3 pieces together, they don't actually make a triangle. So when they're asking how many solutions does this have, well, it could be 1 if it's a right angle. It could be 2 if it's angled in at an acute angle, or if it's angled out at an obtuse angle. Because this could be a length 10 and that could be a length 10. They're just angled opposite directions. Forgive my horrible drawing. But again, as long as it's the same length, it could either be angled in or it could be angled out, and that would give you 2 different options. Or your 3 numbers is not possible to make a triangle, and in that case it would be 0 solutions. So if they're giving me this right here in my problem, can we draw that picture, please? Let's all draw that picture. Again, I don't know what this triangle looks like. I'm just kind of drawing a free-handed triangle. Telling me one side is 4, one side's 10, but it's telling me angle A is 68. 68 has to go in a very specific spot of my triangle. You guys okay with why I'm saying that? Because little a is straight across from big A. Smiley face for that. Little a has to be straight across from my big A in my picture. Everybody okay with that idea? Always. So my 68 has to go here. Because that's how law of sines works, right? We have to do our big right across from the little. Our big right across from our little. So in order for me to know how many solutions this has, I need to set up my law of sines and I need to solve. So let's try. Sine 68 is to 4. And this one, they don't tell me how much that one is. That's fine. I can just call it sine x is to 10. So let's cross multiply and solve. I have 10 sine 68 equals 4 sine x. We're going to divide both sides by 4. How do we find out what x is? How am I going to type this into my calculator? I have to do second sine. Does somebody want to try it and tell me what their calculator tells them? Your calculator is going to say something specific. Ooh, not this time. So if I do sine -1 of 10 sine 68 over 4. If you try that, your calculator is actually going to say error. It's not able to do it. And if your calculator ever says error, guess what that means? It means 0 solutions. It means it's not possible, given these two lengths and a degree of 68, it's not possible for you to form a triangle. So try that again. Now that you guys know what the correct answer is, when you get home, just play around with it a little bit later. And if you ever need to send it to me, send me what you're typing in, you can do that and I can check over. Yeah, so if you get an error, that just means 0 solutions. It means it's not possible. All right, so I'm not going to give you all these answers today, but I do want you to be able to look it up before your quiz. It says, what types of triangles can be solved using the law of sines and the law of cosines? We went over a couple of them today. So some of them you're going to be able to cross off completely and say, nope, I'm not able to use either one to solve that. Other ones you're going to circle. The ones we did today for sure, we had a side-side-side problem. What else did we have today? We had, I don't remember what the other ones were. So you could pop back through and write down which ones they were, but also the online slides are going to give you these answers this week too. So know which ones can be solved with each law, and it will serve you well on your quiz. So week 13, again, your secret phrase is just going to be to answer what kind of triangles are you able to use the law of cosines with. So is there a specific kind? Is it only with right triangles? Is it only with not right triangles? What kinds are they? And that finishes up this week. So I hope that you guys have a great week. Again, Unit 5 should be much, much easier now that we've come across Unit 4. So good luck, guys. You'll do awesome.